Hello dear students, good morning. I'm teacher Madeline Ilagan and today we will going to discuss the minerals and rocks. Are you excited? But before we can start, can I request everyone to rise and start our day with a prayer. Let's bow our head and feel the presence of our Lord. Now you can now take a seat. So now let's check your attendance. Okay, it's a good that you are all present today. So in this morning, we will going to discuss or focusing on about minerals and rocks. Let's just take a quick review or recall. Who can give their understanding about minerals and rocks? Okay, thank you. So let's proceed to our objectives. After this lesson, you should be able to identify common rock-forming minerals and their physical and chemical properties. Classify rocks into igneous, sedimentary, and metamorphic rocks. And lastly, appreciate and value the importance of minerals in our society. So before we can start our discussion, take a look at this picture. What do you observe in the picture? It's talk about what? Yes, correct. It's talk about minerals. Now, let's proceed to our discussion.
The eight most abundant elements on Earth are the following, listed from largest to smallest. Take a look at this table. Here it presents a ranking of elements from largest to smallest element and the present by weight. As you can see, oxygen is at the rank 1 with a percent of 46.60 by weight. It's because oxygen is highly reactive element that combines with other elements. And at the rank 10 is hydrogen with a percent of 0.14 by weight. Now let's proceed to the definitions of minerals. Minerals is defined as natural occurring inorganic solids with a definite chemical composition and ordered internal structures. It's said to be the building blocks of rocks. It's a combination of specific arranged in a particular repeating three-dimensional structures. The atoms of elements in minerals form a crystalline structure called crystal lattice, which is responsible for the shape of minerals. So we all know that Earth crust is composed of elements which is turn up minerals. Earth crust composed of many rocks which compose of one or more minerals. So mineralogy is the study of minerals.
Now, let's proceed to the classifications of minerals. There are four classifications of minerals: the siliceous minerals, the non-metallic minerals, the metallic minerals, and gem-metal minerals. Siliceous minerals. It is the most abundant minerals, also contain chemical elements, silicon and some aluminum, sodium, potassium, hydrogen, and oxygen. Some of its uses are making optical instrument, making of porcelain and enamel, and one of its examples is the feldspar. Non-metallic minerals contains carbonates, sulfates, and other compound or native elements of sulfur. Some of its uses are making manufacturing of cement and making explosives. Its examples is the calcite. Metallic minerals. These ores have been formed due a large process of chemicals and physical changes. Some of its uses are used in electrical wires and paint pigments. Its examples is the copper. So last one is the gem minerals. They include precious and semi-precious stones. It is also known for their color, lusters, and hardness. It's used for jewelry and its examples is the diamond. Now that we are done to the classifications of minerals, let's now proceed to the properties of minerals. Properties of minerals. Each of the approximately 4,000 minerals have a distinct set of physical properties, features like a cleavage, fractures, lusters, colors, and crystallographic habits, color density, magnetism, taste, feel, and acid reactions response. These physical properties are useful for identifying minerals using a systematic method called Dana classifications. Crystal structures. Minerals may be classified based on their crystal structures. Crystal structures describe the orderly geometric spatial arrangement of atoms in the internal structures of minerals. Crystal habits. It refers to the overall shape of the crystals. It is the outward appearance if the mineral's crystals forms. Cleavage. Cleavage refers to the mineral's resistance to being broken. It describes how a mineral breaks along a weakness plane. The quantity of cleavage can be describing in how clearly or easily the minerals breaks. Luster. The lusters of minerals describe the appearance of light reflected form of mineral surface. The color. Color is the most obvious mineral's properties. It is not a reliable feature of identifying minerals because it can be altered by chemical impurities within the structures. Stripe. It is the color of the minerals. It is the powdered form obtained by rubbing the minerals across of the face and glazed porcelain. The hardness refers to the mineral's resistance to scratch. These properties is dependent on the chemical compositions and the crystalline structures of a mineral. The most common scale of measurements is the Mohs scale. It is prescribed by 10 indications. A mineral with a higher index can scratch those below it. Since the minerals of most scales are not always available, there is another way of identifying the hardness. It is through the field hardness of scales. This is done by the rubbing of minerals against the finger or other tools. Let's proceed to the importance of minerals. Indeed, that plays a very fatal role in our lives, and as much as the economy in our country is concerned, we should be aware of how to conserve and preserve the richness of our natural resources. The minerals deposits are further classified into two, the metallic and non-metallic. Here in the table, it presents the non-metallic and metallic minerals and the locations and its uses. Now that we are done to discuss about minerals, let's proceed to the rock cycles and classifications of rocks. Rocks are the common that most of us take them for granted. Rocks is everywhere. I'll ask you everyone, if mineralogy is the study of minerals, what branch of geology that study rocks? Okay, very good. It's petrology. Petrology is the study of rocks. Let's define rocks. Rocks as a natural occurring coherent aggregate of one or more minerals or organic matter. It is found in lithosphere, which is derived from the Greek word lithos, which means stone. Rocks are classified by how they form, their compositions and texture. Take a look at this picture. What do you observe in the picture? Yes, it's a rock cycle. The rock cycle model describes all the processes by which rocks are formed, modified, transported, decomposed, melted, and reformed. These processes occur both on Earth's surface and underneath. Essentially, it is the dynamic cycles of processes and products. When magma is exposed to lower temperatures, minerals and amorphous solids crystallize and solidifiers, forming the igneous rocks. These rocks may then be brought to the surface through a flip where they are exposed to the weathering and erosions. The processes of weathering and erosions break the rocks down into smaller pieces called sediments. These particles may then undergo transportations via agents such as wind, water, glaciers, rivers, and oceans until they settle in in an area where they will undertake this depositions. As more minerals settles on top of each other, temperature and pressures increases and the sediments at the bottom may undergo latifications. Latifications transform sediments into sedimentary rocks. As the temperatures and pressures increase due to the continuous boreal and tectonic activity, the sedimentary rocks undergo the process of metamorphism, transforming into the metamorphic rocks in areas the pressures increase and exceeds the melting points of rocks. Let's proceed to the type of rocks. Generally, rocks is divided into three types of rocks. These are the igneous rocks, sedimentary rocks, and the metamorphic rocks. First is the igneous rocks or cold crystalline. It is formed from cold magma or lava. Based on its textures, the crystalline textures differ depending on how fast and where the cooling took place. Igneous rocks has its two types. Those are the intrusive and the extrusive igneous rocks. Intrusive igneous rocks is also called plutonic rocks. It is when the magma pushes something rocks below the Earth's surface, cools slowly with the large crystal formations. The resulting texture is called phaneretic, which derived from the Greek word phaneros, meaning visible. Intrusive are also called volcanic form. It is formed when the magma erupts into the Earth's surface or the lava cools quickly with very small or no crystal form. Next is the classifications of igneous rocks based on its compositions. We have three compositions of igneous rocks. First is the felsic. It is rich in silica and they are in light colors rocks. Next one is the mafic. It is poor in silica but rich in iron and magnesium and they are in the dark color rocks. Lastly, intermediate. We have intermediate color like light gray are consisting equal parts of dark and light minerals. The examples of igneous rocks are the pumice, gabbro, basalt, and slate. Let's proceed to other type of rocks, which is the sedimentary rocks. Sedimentary rocks is formed when deposits cold sediments which is hardened, cemented, and packed together. It is formed from latifications, a process of cementing soft and consolidated sediments into hard rock. Next is the types of sedimentary rocks. There are two types of sedimentary rocks. Those are the clastic and the chemical rocks. Clastic is formed by weathering process which break down rocks into pebbles, sands, and clay particles by exposures to wind, ice, and water. Clastic sedimentary rocks are named according to the grain size of sediment particles. Chemical rocks made from the precipitations of water which is broken down into two categories, the crystallines and the organic. Crystalline rocks form from a chemical process also known as the evaporates and precipitates. Evaporate sedimentary rocks formed by the evaporations of water. Precipitate forms when water is so full of a dissolved minerals that the mineral no longer dissolve and crystallize in the water. Bioclastic or biochemical sedimentary rocks, made from the compacted organic matter, the only rock that contains fossils or evidence of life. Depending on the grain size, an organic sedimentary rock can be chemical or plastic. Example of this is the cold biochemical limestone fossils. The examples of sedimentary rocks is the limestone, shale, and silt. So now let's proceed to the metamorphic rock. Metamorphic rock formed from a previous igneous and sedimentary rock changes due to the high pressure and temperature. The changing of rocks for igneous and sedimentary rocks is known as metamorphism. Metamorphism could be contact and regional metamorphism. Contact metamorphism rock is converted to metamorphic if it is direct contact with a source of heat such as the formations of marble from the limestone which is heated to the high temperature. Regional metamorphism is increased pressures and temperature is due to some processes known as plate tectonic. These are classifications of metamorphic rocks Exploited minerals are flattened, drawn out and arranged in bands and parallel layers such as rock. Foliated minerals are flattened, drawn out, and arranged in bands and parallel layers such as rock. Foliations forms when pressure squeezes the flat or elegant minerals within a rock, so they become aligned. These rocks develop a platy or sheet-like structures that reflects the directions that pressures was applied. Unfoliated rocks such as phthalates, z's, and slate have a layered or banded appearance that is produced by exposures to heat and directed pressures. Non-foliated metamorphic rocks such as hornfels, marbles, quartzites, and novaculite do not have a layered or banded appearance. Examples of metamorphic rocks are marbles, quartzels, and slate. Now we are done to discuss the minerals and rocks. Thank you everyone and thank you for listening.